So here we have a problem. It says your new co-op is at a tech company coding part of their website. Part of the company's site is a form which they only want to ensure can be filled out by humans, not computers. And so to achieve that, they decide to use a CAPTCHA to detect computers trying to use the form. And their current system uses a randomized distorted string of 6 characters, which is either uppercase letters, lowercase letters, or digits 0 through 9. While humans can answer the CAPTCHA correctly 99.99% of the time, the company estimates computers can only recognize distorted letters, not the digits, and will only answer CAPTCHAs correctly if they're composed of those characters only. So the company estimates 80% of the users accessing the site are humans, and they want to know what is the probability that the user is a human given that they answered the CAPTCHA correctly. The first step of the problem is going to be using Bayes' theorem. So here we have the probability that the user is a human given they got it correct is equal to the probability that they got it correct given they're a human times the probability that they're a human all over the probability that they got it correct. And we actually already know all of the values except the probability that the user gets it correct. So I just rewrote the Bayes' theorem formula up there. And now we're going to use the law of total probability to find the probability that the user got it correct. So here we have the probability that the user got it correct is equal to the probability that the user got it correct given that they're a human times the probability that they're a human plus the probability that they got it correct given it's a computer times the probability that it's a computer. And we actually know 3 of these values already. These 2 we saw in the previous part that come directly from the problem. And then the probability that the user is a computer is the complement that the user is a human. So we just say 1 minus probability of a human, which would be 1 minus 0.8, which is of course 0.2. So now the only part that we have left to solve is the probability that the user got it correct, given that they're a computer. So now we have, this is our Bayes' theorem step, and we also have the law of total probability step. And now we're just calculating the probability that the user gets it correct, given that they are a computer. So for this, we just use the formula of the cardinality of the event space divided by the cardinality of the sample space, which in this case would be the number of CAPTCHAs the computer can solve over the total number of CAPTCHAs. So to calculate how many CAPTCHAs the computer can solve, we look at the problem where it says the computer can only recognize the distorted letters, which, since we have both uppercase and lowercase, will be 26 plus 26, which is 52, all to the power of 6, since there are 6 characters per CAPTCHA, which is 52 to the power of 6. For the total number of CAPTCHAs, we have the same 26 plus 26 for all of the letters, plus 10 for the digits 0 through 9, so that's 62 to the power of 6, meaning that the probability that the user gets it correct, given that they are a computer, would be 52 to the power of 6 divided by 62 to the power of 6, which is 52 divided by 62, all to the power of 6, or about 34.8%. So this is our Bayes' theorem step that we calculated in the very beginning. This is the law of total probability, and this is what we just calculated, the probability that the user got it correct, given that they are a computer, which is this 52 divided by 62 to the power of 6. Using this and this part, we can calculate the probability that the user got it correct, which is 0.9999 times 0.8 plus this 52 divided by 62 to the power of 6 times 0.2, which is somewhere around 86.9%. Now we can take that and plug it into our Bayes formula step to get what we were after in the first place, the probability that the user is a human, given that they answered the CAPTCHA correctly. And so if you compute this out, we already did this before, this is about 92%. So that's the probability that the company was after in the first place, calculating what the probability is that their user is a human, given that they answered the CAPTCHA correctly. So to recap what we did in this problem, we used Bayes' theorem to calculate what we were after throughout the entire problem. We used the law of total probability to calculate that the user got it correct. We used the definition of probability to calculate that the computer got the answer correct. And we also, within that, used counting to calculate the total number of CAPTCHAs and the number of CAPTCHAs that a computer can answer correctly. So thank you for watching this video, and hope you enjoyed.